Okay, so today I want to start off by giving you guys a little review. So I'm going to have you grab a piece of paper, pencil, calculator if you have it. We're going to start out with two problems. One of them, I want you to take 52.738 degrees, and I want you to convert that into degrees, minutes, and seconds. The second one, I want you to take 31 degrees, 39 minutes, and 24 seconds. Now I want you to convert that into decimal degrees. I'll pause for a minute and let you guys give those a... Okay, so let's take a peek. So the first one here, 52.738. We're going to subtract the 52 because we're going to keep 52 degrees. That's 52 degrees. So we're left with the 0.738. So we're going to take that 0.738 and we're going to times 60. Good. Gives us 44.28. So we're going to keep the 44. Back over here, we're going to subtract 44 because we already used the 44 minutes. 0.28 is going to be, once again, times 60. 16.8 seconds. So 52 degrees, 44 minutes, 16.8 seconds.
It's a really cool way to delve. You can just do that with the Google button.
Yep.
That's awesome.
And that's the easy one to do with the calculator, is that one. So now the next one, 31 degrees, 39 minutes, 24 seconds. If you have the button on your calculator, you can enter it just as I said it there. 39, select the degrees. 31, select degrees. 39, select the minutes, and so on. And when you hit equals, it'll automatically turn it to decimal degrees. But if we were doing it manually, we would start out with the seconds. Take 24 divided by 60 to turn them into minutes. So that is now 24 seconds is now 0.4 minutes. So this is now 39.4 minutes. So I have the 0.4. I'm going to add the 39 to it. So I got the 39.4 minutes. Now I'm going to convert those minutes into degrees by dividing by 60 again. That gives me 0.6. I missed a zero there. That should be 0.65666. So this is 31.6567 degrees. How many got both of those right? Cool. Well, then let's take the next step. A little bit of a review from when we did measurement operations. If I have 8 feet 9 inches plus 4 feet 11 inches, how do I add this? Now we can go start on the right, work our way back to the left, just like any whole numbers.
Add up to 12 and then add a foot.
Gotcha. So 9 and 11 makes 20 inches, and since that's more than 12, we have to break that down into feet and inches. That's 1 foot and how many inches are left? 8 inches. So we're going to keep the 8 inches, carry the 1 foot. So now we just add 1 and 8 is 9, plus 4 is 13 feet, 8 inches. Well, the very same concept applies to this. I want you to try that one on your own, and we're going to discuss. See if you can get it to work. I'll give you a couple minutes, then we're going to discuss it in a second. So if we start going right to left, we're going to start with the seconds. 47 plus 18 is 65. Now, of course, that's more than a minute. There you go. We got the 5 seconds, and the 60 seconds makes 1 minute. So we're going to carry the 1. So 1 and 29 is 30, plus 53 is 83. And, of course, that's more than a degree. So we got 23 left if we take out 60. Carry 1.
33 plus 19 is 52.
So that's 52. Good. Perfect. Do we have any questions on that? It's working out okay? How many of you got that one right? Cool. Well then, how about something a little bit more difficult? subtraction. Give this one a shot. So when we go to subtract, 18 minus 52. Can't do it. What do we have to do?
Take 1 from minutes.
Okay, so this is 36. This becomes
78.
perfect. We have to add 60, so that's 78. This is now going to be 26 seconds. Then 36 minus 41.
Degrees.
So this is 50. This is
Add this 96.
96. Got to add 60. So 96 minus 41.
5.
55 minutes. And then 21 degrees. Beautiful. How many had that one right? Cool. You're paying attention today, Cody. Let's try that one. Let's discuss this one. So, 33 times 55 is 165. We're going to have to take out more than 1 minute here. How many are we going to get out of there? 2. We take out 120. It'd be 2 minutes, leaving us with 45 seconds. 5 times 42 is 210. 5 times 42 is 210. Plus 2 is 212. You add the 2 after you multiply, not before. Okay. So now I can take out 180. That's 3 60s. That leaves me with 32. Now 5 times 18 is 90 plus 3 is 93 degrees. Do we need to try another one of those? I'm thinking so. Try this one quick. So, 39 times 4. 156. How many minutes can we get on that? 2, which would be 120 seconds, right? So that leaves us with 36 seconds. Carry the 2 minutes. What's next? 57 times 4, which is 228. Plus 2 is 230. How many degrees can we get out of that? 3. So that'd be 180. Carry the 3. We're left with 50. And then 4 times 14 is 56. Plus 3 is 59. How many had that one right? How many have no clue how to do it? How many just want to go home and cry? There you go.
I have a question.
Yes, sir.
How come when you carry over from minutes to seconds to minutes, to degrees, when you add that remainder, how come it's crucial it's after you multiply?
Well, because, here, I'll show you. Let me do a smaller example here just to, so we got 12 degrees, 18 minutes, and we go times 5, right? Technically what you're doing there, remember we talked about that whole carrying process at the beginning of the fall semester? It really doesn't happen until after you do everything else. Technically what you could do is 5 times 12 is 60. 5 times 18 is 90. Well, the 90, you're going to take one of them and put them over here to make this 61, and what's left is 30. The carrying happens long after the multiplication is done. Because what it is that you carried here, this 3 that you carried, that's already been multiplied. You don't have to multiply it again.
So that's where I'll get around that.
Yeah. So that's why you got to multiply the 14 first and then add the 3 that you carried to it.
Okay. Does the example on the right, will that work every time?
It does. It's just a little tricky. I mean, if I were to do this problem here that way, 14, 57, 39. It gets a little messy. 4 times 14 is 56. 4 times 57 is 228. 4 times 39 is 156. Okay, I usually start carrying at the right, working my way back. So I take out 120, leaving me with 36 here. Bringing a 1 over here, this is 229, or sorry, 2, this is now 230. Well, I'm going to take out 180, which leaves me with 50. Carrying the 3, this is now 59. You can do all the multiplication first and then go back and carry later, technically. Okay. For some people it does. And that's the way it actually was done like 150 years ago.
That's predated.
Yeah. But it doesn't matter. I mean, it works, and it's not like it's not something that hasn't been proven before. You bet. I'm going to try this one.
I have a question before we wait for it.
Yeah.
Okay, so we're working with the degrees, minutes, seconds.
Yep.
What? Give me an application. I mean, I can understand adding the degrees, and I can understand the subtracting of the degrees. Give me an application for multiplying or dividing.
If you're going to multiply or divide, normally you're multiplying by 2 or 3 at the most, because you're stacking wedges together or things like that. If you have wedge cuts or whatever, and you're stacking them together or something like that, and these are all the same angles, so you got to figure out what's your total angle or things like that. 2 or 3 is about the most you ever multiply by. Dividing up, same type of thing. If you have a wedge and you're going to split it, dividing by 2 is probably your most common application. You have a wedge, you're going to split it in half.
Okay,
But we have to take it that next step further.
well, I'm just saying, tell me an application that this would be used for. That's what I'm getting at.
There's not a lot of them. I'll be totally honest with you. I mean, I'm stretching even what I just told you is stretching a little bit.
All right.
So here's one. Divide this one by 6. See what you can do with it. So let's take a peek at this thing. We've got 42 degrees, 27 minutes, 36 seconds. And that's one thing. If you're trying to punch in the calculator, it'll probably spit it back out in decimal degrees. You got to convert it. Yeah.
I got 42.46.
Okay. Well, that's the original number. It didn't divide it.
Sound a little more correct.
Something. Yeah, it sounds closer. So here.
So you punch it in and then
hit equals first, then divide by 6.
And then divide it. Okay.
Yep. So 6 goes into 42 7 times. It's 7 degrees. And that's clean. It's all gone. We used up all 42 of those. 6 goes into 27 4 times. 4 times 6 is 24. So there's 3 minutes left over. So before we do anything else, and this is where you're just a little bit off yet, before you do anything else, we got to convert those minutes into seconds. 3 minutes is how many seconds? 3 times 60 is 180. Now I bring down the 36, that's 216. 6 goes into 216, how many times? 36 times.
Same equation, just doing it the wrong way.
Yep, you just didn't carry it back over there.
No. Oh.
Go ahead.
Did I get screwed up because I divided my seconds? Is that what happened?
Yeah, it divided your seconds first.
So then if I
Then you divided by 6 again. So if you didn't have that divided by 6 in there the first time, it would have worked.
See, if I had done it from the other side, I would have been able to catch that when I was doing it backwards.
Yeah. Okay, let's look at another one here. I'll throw it up here. We'll give Jason time to do this over again too. We'll try that one. So I'm going to write this out again as long division. Five goes into 35 how many times? Or 37 how many times? 7 times. 7 times 5 is 35. So there are 2 degrees left over. What do we have to do with those? Times 60 means that's 120 minutes. So now we bring down the 53. It's 173 minutes. Then what? Divide by 5 would be 34. 34 times 5 is 170 minutes, which means we have 3 left over. What are we going to do with those 3? Times 60 to make them 180 seconds. Bring down the 25. It's now 225 seconds. And then divide by 5 would be 45. Exactly. Uh-oh.
41.
Yeah, that should be 225. This should be 205. That would make that 41. There you go. Now you guys got it right? Okay, cool. Well, let's move on to our next section, what we're planning on doing here. So what we want to look at today, we talked about these calculations with angles. How do we actually measure the angles? We mentioned it briefly yesterday. We have this tool called a protractor. And the protractor, of course, is a half circle. Bless you. And I'm going to do it, a lot of them actually are hollow in the middle. They actually have their 0 point like right there somewhere. Or their vertex point, I should say. Then they've got 0 and 180 on each side. We talked about that a little bit too. It's double numbered. The top here is just 90, but like right here where it's 45, that'll be labeled both 45 and 135, and it depends on what direction you're coming from. Same over here. That's 45, 135. Probably 135, 45 on the other side. But you guys get the picture. And when we measure our angles, we place the vertex of the angle at that point there, wherever it's marked. Some protractors it's on the bottom edge, some it's up a little ways like this one. You have to make sure you know exactly where that vertex has to be. And then one side of the angle has to be lined up on this baseline down here. Doesn't matter which side, which direction. For example, let's say that we line it up going in this direction. And our angle is like this. And we read our protractor and we look up here. And I know I exaggerated my markings a little bit, but let's say that this is 80 and this is 75 here. Of course, this is also going to be marked 100 and 105. Which numbers are we going to use? The 100, 105 or the 80, 75? Why? Why are we going to use the 80, 75? It's an acute angle, which means it's going to be smaller than 90 degrees, so we use the numbers that are smaller than 90. So that means we start, 75 is the smaller number. We count up from there towards the larger number. 75, 76, 77 degrees is that angle. Make sense? You're always going to be counting up from the smaller number towards the larger. The protractor itself is relatively simple to use, so we're not going to spend a lot of time on that. But the next step, you guys might actually be doing some machining that is precise enough that you might use a universal bevel protractor or a vernier protractor. Yeah, I'm sure there's a few of them in the shop. So the bevel protractor, universal bevel protractor, is an instrument that is set up to, it actually sets on the surface of the object so that you can measure the angle. And on the universal bevel protractor, you're going to read an indicator. It's got a bar, kind of like the top bar of the regular protractor, with your markings on it. Let's say this is 40 degrees here. 1, 2, 3, 4, 45. Pretend those are evenly spaced. So anyway, that's your main scale. Those are the degrees. And then generally what happens is there's a vernier scale. Let's say we have 0 here. And that vernier scale goes in both directions. Like this. Now, most of the ones I've seen, many of the ones I've seen only go down to 15. The markings are 15 minutes, not, 5. This is marked down to 5 minutes instead of 15. Because you can see there's 2 marks in between. Around here, like I said, going less than 15-minute or even 5-minute increments I've seen. I've never seen a shop in this area that goes down to a single minute.
What's that? What 5 minutes is it? 1/12 of a degree?
1/12 of a degree, yeah. You start getting down below that, you almost need lasers to do your measurements, because any speck of dust is going to throw you off. So how would we read this angle here? Well, we read the main scale up here. Remember, this is the main scale. We read that at the 0 of the vernier scale. This blue scale on the inside is the vernier scale. Where's that 0 lining up right now? Well, it's between 43 and 44. It's not to the 44 yet. So that is 43 degrees. That is the first common mistake that is made. They look at that and say, well, it's closer to the 44. It doesn't matter. It isn't to the 44 yet. So it's only 43 degrees. Because this vernier scale is going to tell us how far we are past the 43, how close we are to the 44, in other words. Now, the vernier scale, you see, goes both directions from the 0. How do we know which direction to go? Well, we look at the main scale. On the main scale, it's increasing going this way, correct? So we read the vernier scale going that same direction. Where's our first mark that lines up? This one right here, which is, well, this is 15, 20, 25, 30, 35, right? So that is 43 degrees, 35 minutes is what that's reading. Let's try to draw out another one. Yeah, it's a lot like a mic. Okay, on this one, you guys read it for me. Tell me what this thing reads.
21
Okay, yeah, here's the 0 right here. It's between 21 and 22, so we got to go with the smaller one, 21 degrees. Then do we read this side or this side?
That side.
The left side, good. Because the main scale is increasing going in that direction. 45 is the one that lines up, so that is 21 degrees, 45 minutes. What do you guys think? Can we do these? In your packet, I want you to check for me. Is page 275 in the packet you already have, or do I have to grab you a new packet? It's in there. I want you to do all of 1 through 16. Tomorrow when you walk in, I might randomly pick 1 or 2 of those and just have you jot down your answer and turn it in as a quiz grade, just to make sure we're reading these right. Okay? Monday, I mean, yeah, not tomorrow. You know, tomorrow isn't the next time you walk into my class. How about when next we meet? How's that?
There you go.